Hi guys. Right now we're going to work with our digestion system foldable. Okay, so you will have a paper that looks like this, zooming out so that you can see, or zooming in and zooming out. There's a line on it. You need to fold the paper at the line. So that you can just see the line, fold the paper. So it leaves a little flap down at the bottom. I'm going to zoom in so that you can see the flap. And on the flap, you're going to write digestive, process, foldable. So I'm going to zoom in some more. Digestive, process, foldable. And then I'm going to move it over. You're going to write your name. So fill in your name. So you have a little bit, the paper's folded, and it folds up, and then you can see the foldable. I'm now going to cut with some scissors by the words. Let me zoom out a little bit. Okay. So you cut between the spaces of the words. Then you're going to draw a little box. So draw a line at the bottom where the fold is. Then lift the paper up and draw a line down. Draw a line at the bottom. Then lift the paper up. Then draw a line at the bottom. Okay? So we're going to, you have flaps that fold down, physical and chemical changes, energy transformation, large molecules broken down to smaller molecules. So I'm going to start with physical and chemical changes. I'm going to zoom in so that you can see what I'm writing. Okay. So I'm going to make a T-chart that shows physical and chemical changes. Let's keep zooming in. Okay, let's write the word physical and chemical. Okay, so in a physical change, you get the same substance after the change. But the change might look different. After you chew up your food, it looks pretty different, but it's still just chewed up food. It's just in small pieces. For chemical, you will make, after a chemical change, you make a new substance. So what's an example? What could you see to show you that you have a new substance? You might have a color change. You might make bubbles, make a gas. You might change the temperature. It might get hot or cold. Okay, so those are some examples of a chemical change. Physical makes the same substance and it will look different. Chemical makes a new substance. Make sure you can see the words chemical. You have a color change, or you could have a color change, make bubbles, or change the temperatures. Those are examples of how you can tell a physical from a chemical. So physical and digestion could be chewing your food. That's physical. It's still your food. It was just ground up into small pieces. Or your stomach churning. It's just mixing up your food. An example of a chemical change is saliva. Saliva in your mouth will start the digestion of carbohydrates. Okay, so start the digestion of carbohydrates. An example, an everyday example of a physical change is melting ice. An example of a chemical change is metal rusting. So again, physical made something new, chemical made something different. I'm going to zoom out a little bit to make sure you can see. Zoom. So starting from the beginning, same substance, new substance. Looks different, you could have, it looks very different, but you need indications. Color change, make the bubbles, change the temperature. An example would be saliva. Starts the digestion of carbohydrates. An example could be your stomach churning or chewing your food, could be a physical change. An everyday example is melting ice or metal rusting. You need to know the difference between physical and chemical change. Okay, moving over. Oops, let me get it over there. Let me zoom out a little bit. Okay. Energy transformations. Make sure you are underneath the middle for energy transformations. I'm going to flip up. And where we're writing for between line to line for energy transformations, we're going to go from a chemical change in our food, and we're going to turn that into thermal energy. And mechanical energy. Thermal and mechanical. Okay? Thermal energy is heat. Mechanical energy is movement. Okay? I would like you to add in pictures. Draw a picture of some food. Okay? And your food is turned into heat. Draw a picture of something that represents heat to you. Maybe a fire, maybe a thermometer, maybe a person sweating. Draw a picture of something that represents heat. And then movement. Draw a person or an animal moving. Their muscles moving or making that movement from that chemical energy in the food. Draw pictures. Okay. The final one. Okay. We're moving over to large molecules. Let me zoom out. Sorry, went the wrong way. Large molecules broken down into smaller molecules. We're going to make a chart over here. Large molecules broken down to smaller molecules. Okay, flip open your thing. Flip open your foldable. We're zooming out. Okay, for our foldable, we need something called a macro, M-A-C-R-O molecule. Put a dash. The macromolecule, and then the smaller molecule, and then the element. Okay? So the macromolecule we're going to talk about is a carbohydrate. Okay? And a carbohydrate is made of glucose. The building block of the carbohydrate is glucose. And the elements, carbon, hydrogen, oxygen. Remember when we did CHO, trons, chomp? CHO is the carbohydrate. Carbon, hydrogen, oxygen. Now for the other macromolecule we're going to talk about is protein. A protein is made up of amino acids. And the elements inside the amino acids and inside the protein are the chons. C-H-O-N-S. I'm going to put that S down there. screen went off for a little bit. A protein has amino acids, chons, C-H-O-N-S. So carbohydrate is building block is glucose. Its smaller molecule is glucose. It's made up of carbon, hydrogen, and oxygen. Protein is made up of amino acids. It's made up of chons, carbon, hydrogen, oxygen, nitrogen, and sometimes sulfur. Okay? You need to get this foldable complete. It needs to be turned in with your components. Thanks. Bye.